3.3, solving systems of linear inequalities. All right, so basically we're going to be taking lines, we're going to be graphing them like we've done before. This time they're going to be inequalities, so we need to really think about, do we have solid lines, which would have the less than or equal to, or the greater than or equal to. So again, the equal to part is when we have our solid lines, versus if we have our dashed lines, which are just our less than or our greater than, no equal to part. So just keep that in mind as we go through. All right, so on our first one, graphing, I'm going to take this guy. We are going to rewrite this in terms of y. So I'm going to minus the x. That would give me negative y is less than negative x plus 6. We can't have a negative variable out in front, so we're going to divide both sides by -1. I am going to remember as I do that that means my inequality sign flips, and I have x minus 6 instead. All right, on my second equation, a little easier. I just have to minus my 2x. All right, and if this is unclear, this is a 1.5 over here. All right, so when I do that, I would be left with y is greater than negative 2x plus 1.5. Okay, so let's go ahead and get this sucker graphed on here. So, making my graph. All right, for that first one, we have a y-intercept of -6. So 1, 2, 3, 4, 5, 6 down here. My slope is 1, so up 1 over 1. So I'm going to get a bunch of dots on there. All right, it is a dashed line because there's no equal to. All right, and it's greater than. So right now I'm just going to put arrows where I would be shading. So greater than would be above. And the reason I'm just putting arrows instead of shading is because we know it's going to get messy with a lot of different ones. But if you wanted to do this, you could. Okay. All right, on our second one, we have a y-intercept of 1.5. So I'll put that there. And we have a slope of -2. So I'm going to go down 1, 2 boxes and over 1. Down 2 boxes, 1, 2, and over 1. Do that a couple times just to get that on there. Again, a dashed line on this one because it doesn't have the equal to. All right, and this one's a greater than, so we'd be shading above. Again, if you wanted to, you could do that. And what we really want to bring to our attention, sometimes I use a highlighter in class. I'm going to use my favorite color, purple. But where they overlap, make it nice and dark with your pencil or use a highlighter. That's where our solutions are. Okay, now what we want to get in the habit of is always giving 2 solutions that are in there. So let's see, 1, 2, 3. So I'm going to do this coordinate point here and maybe that coordinate point. So 3, 1 is a solution and 4, 3. Okay, so in your homework, I'll be looking for the graph to match and then 2 solutions in that solution set. All right, let's try our next one. Okay, the first one's ready to graph. It's already in y equals. The second one, we need to move the 2x over. So we'd have y is less than -2x plus 1. All right, let's get this sucker ready to graph. All right, so that first one I'm going to graph in red. Y equals 4, so 1, 2, 3, 4, y-intercept of 4. Since there's no x, that means I have a slope of 0, which means it's going to go straight across. And as I draw that nice horizontal line, I am making it solid because it has the equal to. All right, it is less than, so if you want to, you can draw arrows down so you remember where to shade, or you can just lightly shade. Okay. Second one, y-intercept of +1, slope of -2, so down 2 over 1. Okay, built some maybe the other way. Careful when you are making this line because it is dashed. All right, and it is less than, so we'd be shading below. All right, and where's the overlap? So with your pencil, either make it extra dark in there. I'm going to use a third color and just make it really big and bold. Or you could use a highlighter to highlight that section where there is overlap. Okay, and final part is give me a solution in there. So maybe I'll do like this guy and maybe like this guy. So let's see, that would be -2 for one of my coordinate points, and -1, 2, 3, 4, +2. Okay, so make sure we're graphing and then also giving 2 solutions in there. All right, we are selling hot dogs and spicy sausages at the fair. She only has 40 buns, so she can sell no more than a total of 40 hot dogs and spicy sausages. Each hot dog sells for $2 and each sausage sells for $2.50. She needs to make at least $90. All right, so we've got some equations to make. So first thing is they bring up hot dogs first, so I'm going to call that X. They bring up the spicy sausages second, so I'm going to call that Y. All right, so she's only got 40 buns to use. So let's see, she would have some hot dogs and some sausages, and she has to keep that underneath 40 so that she doesn't go over that and not have enough bread for everyone. Okay. Let's see, what other constraints do we have? We have the money one. So let's look at the money. So the hot dogs are selling for $2. The sausages are selling for $2.50, and she needs to make at least $90, so greater than or equal to 90. Okay, so these are our two equations on here. Now, these two equations we are going to get onto a graph. So let's talk about what we probably need to think about. So on this first one, my x-intercept would be 40. My y-intercept would also be 40. So thinking back to what we did in chapter 2 with that. We need to also do that for our second equation. So my x-intercept on the second equation, 2x equals 40 or equals 90 would give me a y-intercept of, or excuse me, x-intercept of 45. And then probably need my calculator for the other one. So 90, let's see, 90 divided by 2.5. That gives me a y-intercept of 36. Now you'll notice I put these ones just with numbers and these ones I wrote as coordinate points. Okay, so our first set versus the second set makes no difference. It just helps with making our graph. Okay, now we obviously can't be selling 0 of anything, so x needs to be greater than or equal to 0, y has to be greater than or equal to 0. Those are nice to put in there and get in the habit of doing because, again, you can't have negative hot dogs or negative spicy sausages. All right, so when I go to make my graph on here, it'd probably look nicer if you had graph paper. X-intercept needs to get up to at least 45, so I think I'll go 10, 20, 30, 40, 50. Put my scale on there. Now, one thing to keep in mind, is that we have, this is our hot dogs. So I'm going to put hot dogs. Okay, and on the other one, we need to get up to at least 40. So I think I'll go by 10s again. 1, 2, 3, 4. So 10, 20, 30, and 40. Again, these are the sausages. All right, and she's selling them at the fair, so I'm going to title my graph before I forget fair. Okay? All right, so let's get these things on here. On that first equation, I'm going to do it in blue so you can see it a little bit better. We had an x-intercept of 40. We had a y-intercept of 40. We can have exactly 40. If we look back at our equation, it had the equal to, so we're going to make that a nice solid line. On my second one right here, we'll put the intercepts. So we had an x-intercept of 45 and a y-intercept of 36, so somewhere in there. And then again, we can have exactly $90 because it says she needs to sell at least $90, so $90 or more. All right. Okay, so let's see. Let's figure out where our shading is. Okay, so she needs to be above the purple line. And for the blue one, she needs to be below the blue. So we need to think about where the intersection is happening between, okay? And our intersection is happening right in between there that I'm drawing in red. Okay, so it asked us to write a system of equations, which we did, over here in the red right to begin with. And then it asked us to graph it, which we did. Okay, please remember on your graph, you got to have all the pieces. So your scale, accuracy means the label. L is your labels on each side, and T is your title. So let's not forget about any of that, okay? All right, last one we have to cover today is just graphing this guy and seeing what shape it ends up making, okay? So I'm just going to make myself a quick graph. I like to do these in different colors. So my y equals 4, 1, 2, 3, 4. Solid line. Now, because we're graphing so many things on there, I am not going to shade. I am merely going to draw arrows where the shading would be. Okay, our next one, y is greater than or equal to -1, so there's that guy. we would be shading above. Okay, let's move on to our next one. Ooh, let's hope I made this tall enough. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right, and slope of -1, so this guy's coming down. Again, solid line. Whoops, that wasn't very nice. There we go. Okay, and this is a less than, so we'd be shading below. And our last one, we have a +2 on here, and a +2 slope, so up 2/1. All right, and we would be shading, it says less than, so below. So looking at where all of this is going together, we would have underneath the blue, underneath the green, underneath the purple, and above the red. So let's shade in where that would look like. Okay, and it just says, what shape is that? Well, we've got 2 parallel bases, and then we've got our diagonal sides, so this would be a trapezoid.